Alrighty, so today what I want to do is review the elimination method. It's an alternative method if you don't like the substitution method or obviously the graphing. And it's called the elimination method because if you look at the equation, the x's line up nicely, the y's line up, the equal sign, the 10. This actually is a great little foreshadowing of what's to come, matrices. And I'm hoping to show you that since I'm teaching you new stuff this quarter. So the ideal elimination method is this. Sometimes if you add the two equations together, you eliminate one of the variables. Unfortunately, as it's written, I can't eliminate the x's because if I add together, I'll have 4 of them. And if I add together, -3. So I still have 2 variables. So the elimination method works like this. If you can't cancel a coefficient right away, what you do, you have a couple options. I see right away I have a negative sign and a positive sign here. So if I can perhaps multiply this bottom equation by 4 to create 4x plus 4y equals 4. I just made the equation 4 times larger. It's still the same equation, but 4 times bigger. Keep the top equation 3x minus 4y equals 10. And the elimination method now tells me if I add everything, add this, add that, we will have one variable. We'll have now 7x, the y's cancel, equals 14. And now I can solve for x. It doesn't matter if you add two equations and you eliminate the x's or you eliminate the y's, you have to eliminate one of the variables. And it doesn't matter which one you solve for first. I happen to get x first, no problem. X is 2. But you're still trying to find a point of intersection. So remember, go back, either one of these two to solve for the other variable y. So like for instance, this one looks a lot easier. So if I take 2 plus y equals 1 and subtracting 2, oh my gosh, y is -1, and you're done. Hence, it's called the elimination method. You may remember this from Common Core algebra, but we're talking about years ago. Hopefully that makes sense. The question, hold on. Let's look at the next example, then maybe write it down, send me a message. Okay, so the next example, likewise here, I can't add because I'm not going to eliminate an x or y, but I see right away here another alternative is, hey, could I maybe multiply the bottom equation by 3? So the top equation, 3x minus 2y equals 7, stays the same. But this time, if I multiply the bottom equation by 3, 3x plus 3y equals -3. Almost lost my train of thought there. If I, instead of add, choose to subtract, guess which variable I eliminate? The x. That's the elimination method. Some textbooks call it the linear combination method as well. That works too, because if I subtract this time, the x's are eliminated. Just be careful of your signs. This is a negative sign. -2 minus 3 is -5y. And 7 minus -3 is 10. So this time, I'm actually solving for y first, and I get y is equal to -2. No problem. But the only problem I sometimes see is you get in such a routine habit, solve for x first, that you forget what did you solve for first. So if you solve for y first, again, the second equation is a lot easier. You plug that in, x plus -2 equals -1, which is same as x minus 2 equals -1. And if you add 2 to both sides, voila, your answer for x is 1. So the point of intersection would be 1, -2. So those are two different variations of the elimination method that works. Now, could you run into a situation where you may have no solutions? Or what if you get 0 equals 0? So if you remember that from the other video, if the left side and the right side equal, and there's no variables, that means you have infinitely many solutions. So like in this example here, this is example number 9. Again, same idea here. It's like, oh, I don't know what to do, what to solve for first. I mean, the worst case scenario, if you want to, you can multiply the top equation all by 2. So 6x minus 8y equals -36. If you want, you can multiply 3 to the bottom equation, forcing to eliminate the x's. That's cool too. You'll see there's almost too many decisions and too many scenarios I can play through, but they're all going to be mathematically legitimate. So you'll get the bottom equation, 6x minus 3y equals -21. So now if I solve for this, let's see, Just making sure my math is correct. Looks good. Multiply everything by 3. Looks good. Looks like I'm going to subtract. So negative 8y minus the signs change will be negative 5y. Negative 36 minus a negative 21. So negative 36 minus a negative 21. I get negative 15. And divide both sides by negative 5. Negative divided by negative is positive. So hey, we get an answer y equals 3. Now again, be careful. You found y. You could go back to here, 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 here. I would probably go back to the original second equation of 2x minus y equals negative 7. Plug in 3 and solve for x. That works too. Adding 3 to both, again, you watch out those negative signs. You get here negative 4. And dividing both sides by 2, the answer for x is negative 2. So it's an alternative method. It's called the elimination method. Sometimes in textbooks they call it the linear combination method. But this method is actually quite fun to do because it's the precursor to what comes next in algebra, solving by matrices. So we'll be able to solve these with the graphing calculator once you understand matrices.